This video is part 3 of a 6-part series. We are going through the 60 math questions on an ACT practice exam. And in this video, we're going to do problems 21 through 30. Let's get started. Problem 21. To get a driver's license, an applicant must pass a written test and then a driving test. Past records show that 80% of applicants pass the written test, and 60% of those who pass the written test pass the driving test. Based on these figures, how many applicants in a random group of 1,000 applicants would you expect to receive a driver's license? So if you have 1,000 people and you expect 80% of them to pass the written test, that's 0.8, and then you expect 60% of those to pass the driving test, we will just do 1,000 times 0.8. So 800 would pass the written test times 0.6, or 60% of those 800. So it's a total of 480 students. That's 60% of 80% of 1,000 would be 480 students. Problem 22. You're given a, b, and c positive integers such that a to the b equals x and c to the b equals y. Then x times y is going to be a to the b times c to the b, which is ac to the b. And so when the exponents are the same, it'd be like x squared times y squared is equal to xy squared. Because x squared plus y squared, you could write that as xy times xy, right? X times xy times y. And then you could write xy times xy as xy squared. So that is how you would answer this question. It's AC quantity to the b. So 22, the answer is H. Problem 23. We need to simplify this expression. If you look at all of the answers, all you do is just make all the parentheses go away. But I want to show you something horribly exciting. You have 2y and you have negative 2y. So they're just going to disappear. So it's 1/2 y squared 6x plus 12x. Because the 2y minus 2i, that disappears. 1/2 y squared 6x plus 12x is 18x. 1/2 of 18 is 9, so it's 9xy squared, which is A. Problem 24. There are 3 separate ways that you can work problem 24. First, let's set up the equation. An artist makes a profit of 500p minus p squared dollars from selling of paintings. Fewest number of paintings the artist can sell to make a profit of at least $600,000. So we have 500p minus p squared is equal to $600,000. I'm going to subtract 500p and add p squared to each side. And you will get p squared minus 500p plus 60,000 is equal to 0, because I moved everything over to one side. Now, we have learned that we can factor this. That is way number 1. Factor equals 0. It's going to be p and p, because this is negative and this is positive, both are going to be negative. Now, what two numbers added together give you 500, multiplied together give you 60,000? If you think about that and you say, I really don't want to factor that, what's another way? There is another thing called the quadratic formula, and it comes from the quadratic equation. So if you have ax squared plus bx plus c equals 0, which in this case, you put p in place of x, and that is a quadratic equation. You can use a quadratic formula where x, I need to move that over a little bit. Let me rewrite that up here. Ax squared plus bx plus c is equal to 0. then x is equal to negative b plus or minus the square root of b squared minus 4ac, all under the radical, all of that divided by 2a. So if you want to do that for this particular equation, a is equal to 1, b is equal to negative 500, c is equal to 60,000, and then you could say x is equal to negative b, so negative 500 is 500, plus or minus the square root of negative 500 squared minus 4 times 1 times 60,000, all that under the radical. And all this is under 2 times a is 1, so it's 2 times 1. So this is the equation. Let's put that into the calculator. And because this is plus and minus, we're going to do the minus first because that would give you the smallest number. So let's start with parentheses, 500 minus, under the square root, we're going to have negative 500. Oh, you know what? I need to put that inside parentheses, negative 500 squared minus 4 times 60,000. Yeah, out from under the radical, close parenthesis, divide by 2. And I get an answer of 200. So x is equal to 200. And then if I did that again with a plus, I get x is equal to 300. So 200 is the smallest number. So yes, if you put 200 in here and 300 in here, that would be the proper factor. But I'm going to guess that very few high school students are going to come up with the factoring. If you have completed Algebra 2 and you're familiar with the quadratic formula, you could go to the quadratic formula fairly quickly and get that done. But let me show you a little bit of a different way to do it and just use the calculator. So you have answers of 100, 150, 200, 300, and 600. And putting them into this equation, it has to be at least 60,000. So let's do 500 times 100 minus 100 squared. And that gives you a negative number. So, oh, you know what? I did that wrong. So let's do 500 times 100 minus 100 squared. That's 40,000. That's not enough. So let's do 500 times 150 minus 150 squared. 52,000, that's closer. I'm picking these numbers from over here. So now let's do 200. 500 times 200 minus 200 squared equals 60,000. And then you'd get 60,000 for 300. And for 600, you'd get something less than that. So of the answers given, H is the smallest number that gives you 60,000. And you know that because you did 100 and 150. So if you don't want to go or don't remember how to use the quadratic equation, and factoring it is unlikely if your factoring skills aren't real strong, just plug the numbers in and see what answers it gives you. That can be a quicker way to answer multiple choice questions. Problem 25. Last month, Lucy had total expenditures of $900. The pie chart below breaks down these expenditures by category. The category in which Lucy's expenditures were greatest is what percent of her total expenditures. So if her total expenditures were 900, go to which piece of the pie is greatest, which is clothing, 254. So 254 divided by 900 is all you have to do. 254 divided by 900, and that is 28.2%. The closest percentage on that is 28. This one's pretty straightforward. 26, we've got angles. We have angles going on here. In the figure shown below, the measure of angle BAC is x plus 20. So that's this angle. And the measure of BAD is 90 degrees as noted by that. What is the angle of CAD? So you're going to have 90 degrees is equal to, and I'm going to call this angle theta. And theta is a pretty common letter to use for an angle. So 90 degrees is going to be x plus 20 plus theta. Now we just solve for theta. Subtract 20 from each side. 90 minus 20 is 70 is equal to x plus theta. Subtract x from each side. 70 minus x is equal to theta. Theta is angle CAD. So 70 minus x is what we're looking for. So 26, the answer is G. Problem 27. The perimeter in inches of the isosceles right triangle shown has a hypotenuse of 8 square root of 2. Because it's an isosceles right triangle, we know both of these sides are the same size. So I'm going to call this x, and I'm going to call this x because they're going to be the same. So we're looking for the perimeter. Perimeter is going to equal x plus 8 square root of 2. So we need to use something to find out the length of 8. We're going to use the Pythagorean theorem, which is a squared plus b squared is equal to c squared, where c is the hypotenuse and a and b are the two legs. So x squared plus x squared is going to equal 8 square root of 2 squared. X squared plus x squared is 2x squared. 8 square root of 2 squared is 64. 8 squared is 64. Square root of 2 squared, any number, if you take the square of the square root is the number itself, so that's 2. I'm going to divide both sides by 2. X squared is equal to 64. So x is equal to plus or minus 8. And it's always plus or minus because negative 8 times negative 8 is 64. But since we're talking about lengths here, it's 8 and 8. It can't have a negative length. So the perimeter is going to be 8 plus 8 plus 8 square root of 2. 8 plus 8 is 16 plus 8 square root of 2. E is the answer. And remember this because we have another problem coming up where the hypotenuse is 8 square root of 2. And I'm going to refer you back to this problem for how we got the legs of 8. Problem 28. The equation, I'm going to highlight these. This equation, y is equal to ax squared bx plus c, is graphed right here. So this is the graph of that equation. So for all real values of a, b, and c, when y is 0, what following best describes? So when y is 0, that means you're on the x-axis. So what that really means is these 2 points. Those are called the zeros of the function because that's where y is equal to 0. So at both of these points, ax squared plus bx plus c is equal to 0. That's what this question is asking. When y is 0, what best describes it? So there are 2 distinct positive real solutions. X is positive here, x is negative here. That is not true. 2 distinct negative real solutions. Well, you have 1 negative and 1 positive, so that is not true. 1 positive real solution, 1 negative real solution. That is true. And it's possible to have no real solutions, 1 real solution, or 2 real solutions for a problem like this. But for 28, the answer is H. And you will learn more about parabolas and finding zeros in the second semester of Algebra 2. Problem 29. We are dealing with imaginary numbers. And dealing with imaginary numbers, the square root of -1 is equal to I. The square root of negative 1 squared is I squared. Any number, square root of any number squared is itself, so that's equal to negative 1. So if you have an I squared, you can just rewrite it as negative 1. If you have I, you have to leave it as I because it's the square root of negative 1. So we're supposed to take these two complex numbers and FOIL them. So let's do the first two terms. Negative 3i times 3i is negative 9i squared. Outer terms. Negative 3i times negative 4 is negative 12i. Let's do the inner terms now. 4 times 3i is plus 12i. And now we're going to do the last terms. 4 times 4 is 16. Okay, one thing that you should note here is negative 12i plus 12i, those cancel out. So what we're going to have left over is negative 9i squared plus 16. I squared is negative 1. Negative 9 times negative 1 plus 16, that is negative 9 times negative 1 is 9 plus 16, which is 25. The answer is C. Problem 30, last problem. This is a trigonometry problem, and there's tangent, sine, and cosine. Let me go to a new page, and if you have a right triangle, you have an angle theta. This side is the hypotenuse. This side is opposite the angle, this leg. These are two legs, so this is the opposite leg, this is the adjacent leg, that's the hypotenuse, and this is an angle theta, which I'll label as A. We can call this triangle ABC, and I'll just call that angle A. So sine of angle A is going to be opposite over hypotenuse, opposite over hypotenuse. Cosine of A is going to be adjacent over hypotenuse, and tangent of A is going to be opposite over adjacent, opposite over adjacent. And the way that this is taught and remembered is, so let me erase that to rewrite it for a second, because I try to write it in all lowercase. So TOA. Sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So with SOHCAHTOA, let's go back to this problem. SOHCAHTOA. So this is O and A and H. So we don't have an H, so we can't use sine or cosine. Tangent of theta is opposite over adjacent. Tangent of theta is, the opposite is 7 over adjacent is 5, so tangent of theta is 7/5. And you can't use sine or cosine because you don't have a hypotenuse, although you could figure out the hypotenuse because the hypotenuse would be the square root of 7 squared plus 5 squared. That's the Pythagorean theorem. I didn't even think about this. 49 plus 25 is 74. So the square root is 74. So the hypotenuse is the square root of 74. So you could do sine or cosine, but you'd have to have square root of 74 in there, and it's not there. So go with the easiest one, and that's what works. That concludes section 3, or the third video in this series.